Now chapter 17.5 is all about solving quadratic equations by actually plotting the curves out. Now you may recall from even far back as Key Stage 3, we have a pair of axes, we'll plot a graph involving x squared, and I said back in those days it's a quadratic graph, and it looks something like this, wouldn't it? So here we have the graph, y-axis, x-axis, and the usual thing is we just get some x values, calculate the y values, just get sets of coordinates by calculating the y value from the given equation for the quadratic. We'll just plot it, it gets something like that, and this will have a definitely have x squared in the equation because it will be a positive one because of shape. And you may recall that anything that looks like that, the upside down u or the n shape, will be something like minus x squared, etc. Alright, so that's Key Stage 3 sorted. Again, it's like plotting a linear graph. On this occasion it just won't go straight because it's an x squared type graph. Alright, so or a minus x squared type graph, in which case it looks like that. Now how do you solve an equation like this, for example? Well, if you look at the general equation of a quadratic, it's something x squared plus something x plus something at the end, all comes to 0. Now remember, all these can be positive or negative. That can be positive or negative, and the c at the end could be positive or negative. Alright? So you have an equation that goes y equals something ax squared plus, something x squared plus something x plus something. And if it's going to equal to 0 as well, then we're going to see where this graph, this equation crosses the line y equals 0. So where y equals 0, that is, these are the points or points where we're looking for the u-shaped graph or the n-shaped graph to cut across that that axis. So if I imagine I've got something like this, and here we go again, the usual standard procedure. This will be, for example, the graph of y equals ax squared plus bx plus c, and we want to see where this equation interacts or intersects the line y equals 0. Now, get into your head, that is the y-axis, that is the x-axis. But you may recall that the equation of the x-axis is actually y equals 0, because all the y coordinates along this horizontal line here have a value of 0. So how would I look for the solution where this equation equals 0? Answer, there's a value for x right there, x equals whatever, and here have another value for x equals whatever it's going to equal to. Now this one is obviously going to be a negative value. Alright, here we have a positive value. So this graph that cuts the y-axis in two positions, there and there, will have two solutions. Let's draw another one up here. Just try and keep it on the same page. So that graph has two solutions, a negative one and a positive one. Something like this also has two solutions, because here we have the x-axis, in other words the line y equals 0, and here we have the y-axis. But here also, look, we're intersecting with the line y equals 0 here and here. There are the two solutions, but they're both positive. So x equals whatever, but it will be positive. Here x also equals whatever it's going to equal, and it will also be positive. So here we have two positive solutions. Here we've got two solutions, one negative, one positive. Here we still have two solutions. Alright, one negative. So that should be negative, shouldn't it? Sorry, just backtrack there. That's a negative. Sorry, both positive. I'm getting tired. Okay, so here, two positive solutions, one there, one there. And backtracking over here, we've got a negative solution there and a positive solution there. Again, I'm trying to fit it onto one page, so I'm going to be really careful. So what about when it goes like this? Now, yep, well, I've drawn it badly, but here I've got a solution here. X will be something, and here as well x will also be something, but look, they're both in the negative territory here, so x will be negative there and x will also be negative there. And again, this is the line y equals 0 or the x-axis, and this is the y-axis or the line x equals 0. But anyway, don't worry about that. Just study this page for a minute. You might like to pause the video and just look at what I've done. Let me just reiterate what's going on. Usual thing, quadratic equation that's been plotted as a graph. We'll cut the y-axis in two positions. It could be a negative solution and a positive solution. We could have two positive solutions here where it cuts the line y equals 0, or we could have two negative solutions. There is another scenario. I'm going to try and make it fit right here. What about this then? What about this? This is the graph cutting the x-axis is just one point right there. It should have actually been touching, but I couldn't make it fit perfectly. So here I have just a single solution. So it's one solution, and it happens to be a positive value of x. X will be whatever it's going to be, but it's positive. Had I drawn it, for example, on this side, I'm going to have to change colour so it stands out. There it goes. So here we have an x value again, a single one, x equals whatever. It'll be a negative solution because it's in the negative territory where the minus x values are. So look, we can have two answers, both positive, two answers, both negative, two answers, both either positive or negative. And here we just get one solution where the line just touches the axis in one point and takes off again. It could be positive or negative solution. Sorry, negative or positive solution. And it's even possible to have a graph with no solution whatsoever. So this is an example of a quadratic equation that's plotted on a graph, something like that. Because this graph does not intersect or interact with or pass through the x-axis at all. It does not cut through the line y equals 0, therefore there is no solution. Not even one, alright? This axis does not cut through that given equation that's been plotted there. So no solution whatsoever. Alright, so that's a bit of an introduction to the way things might look if you were to plot one of each of these possibilities. Now, let me extend it slightly by going to a fresh page. Right, now look at this. Do you remember this equation here? The quadratics formula, x equals minus b plus or minus the square root of b squared minus 4ac all divided by 2a. Now again, that the a value is the value in front of the x squared, the b value is the value in front of the x, and the c value is the value at the end of the quadratic. Let me just rewrite that. So for example, y equals ax squared plus something x bx plus c, and we want to solve the equation therefore ax squared plus bx plus c equals 0. This will be the form that you'd use in order to calculate all the y values to plot a quadratic graph, for example. In this form here we just pump the values in front of the x squared, the x and the value of c into the quadratic formula and get two solutions. Again, from previous videos you'll recall that if it's positive then you get one solution. If you go for the negative route you get another solution. Therefore using this formula will give you two solutions. Or will it? Now check this out. What happens if b squared equals 4ac? What would happen? Well, whatever b squared is, 4ac will also be the same. If you take away 4ac from b squared and they both have the same value, you end up with a square root of 0. So what do you get actually? You get x equals minus b plus or minus 0 divided by 2a. Well, clearly 0 doesn't do anything to that, so we've effectively got x equals minus b divided by 2a. And so what would you get? Therefore we just get one solution. Alright, before you even plotted any graph, you can just calculate the value of b squared and 4ac, and if they're equal, you know you're going to get just one solution. Because look, the square root of 0 is 0. What happens if b squared is greater than 4ac? Well, if b squared is bigger than 4ac, then when you take away 4ac from b squared, you end up with a number under the square root which you can square root. So therefore you'd get minus b plus or minus a certain number divided by 2a. Well, that would give you two solutions, because you can add this number on or subtract this number from the minus b, and then of course you divide by 2a. So what happens if b squared is greater than 4ac? Simple, you get this. X is going to be minus b plus or minus the square root of a positive number. Okay, it's a little bit sloppy, but I want you to see the words. If I add or take away a positive number and then divide by 2a, I will get two answers. I will get the positive solution and the negative solution. Well, I'm not saying the solution is going to be positive or negative. I'm saying if we go down the plus route, we'll get an answer. If we go down the minus route, we get a separate answer. Therefore, two solutions. Now, it's not very tidy. How's that? Good. Now, look at the next one. What happens if b squared is less than 4ac? What's going to happen now? What's going to happen? There's be a question mark. Look at this. If this is smaller than that, then 4ac is going to be bigger than b squared. If I try and take away a bigger number from a small number, I'll end up with a number that's negative, and therefore when I try to press the square root button, it won't work. There will be no solution. Look at this picture then. X is going to be minus b plus or minus the square root of a negative number. Well, if b squared is less than 4a, when you calculate it, you will get a negative number. And when you try and press the square root button, the calculator will give you something like error or something like that. So what's going to happen there? No solution. Right, so let's just reiterate then. If b squared equals 4ac, you get one solution. Look, I've calculated the one possible answer there. If b squared is greater than 4ac, you get the normal thing you'd expect, two solutions. If b squared is less than 4ac, you end up with a negative number under the square root, and therefore you end up with no solution because you won't be able to square root that negative number. So that's essentially it. Let's just flip back a page. You need to study those graphs there nice and slowly. What's this? Is that relevant? Yep, sort of. That's the intro to the whole video. 1, 2, 3, 4, 5. Those 5, 6 scenarios just there. And also, if you want to do it by calculation, the way these different parts of the equation hang together. One solution, two solutions, no solutions. Study that. Now, I don't think you need to know this in any great detail, but just be aware of it, because it will help you to understand that when you plot these quadratic graphs, why there will be sometimes situations whereby you get one solution, sometimes two, sometimes both positive, both negative, one of each, and very occasionally no solution whatsoever. So this is an introductory video. There's no questions like this, but I felt you should have the background before we actually do the graphs as well. Alright, so put that away, shall we?